Hey everyone, it's You'll Be Blessed here, making it clear, making it plain, opening up the heavens for my teaching is like spring rain. And in this segment, I'm going to show you how to write the chemical names for ionic compounds when given the chemical formula, when specifically handling those transition metals. Let's go. Now, in this particular segment, since we're going to be talking about transition elements, it's important to realize where they are on the periodic table. They are right smack dab in the middle, groups 3 through 12. All right. And what's special about the transition metals is that they have multiple ways of forming compounds because they have multiple electron configurations that favor stability or stable ions. Okay. And in order to distinguish the difference between the different ions, we have to use what are called Roman numerals. Roman numerals are using letters like I and V. In this case, that's pretty much what we're going to stick with. There are other letters involved, but most of the ionic charges don't go past 7. Some key things you need to note is that, IV is specifically for 4, okay? V is for 5, and then VI is for 6. That tends to confuse people if you're not familiar with using Roman numerals. Also, when it comes to using Roman numerals, we need to understand that the Roman numeral is specific to the actual charge on that element. So if the Roman numeral is 3, we're going to use the atom that has a positive 3 charge. Now, if an atom has a positive 5 charge, then we're going to use the Roman numeral V when it's time to write its name. So the Roman numeral is directly related to the actual number of the charge, the positive charge. All right, so let's start this reverse process of writing chemical names for ionic compounds. The formula that we've been given is Fe3P2. The first thing we're going to do is start from the bottom. We're going to write our formula, Fe3P2, and we are going to reverse the crisscross. So this time we are going to take the subscripts, put them back at the top so that they become superscripts, switch them, and put positive and negative signs on them. That's a lot of work, but you can do it. I know you can. When we do that, the 2 goes to iron and becomes a positive 2. The 3 goes to phosphorus, and we have a negative 3. Here's one of the most important steps when doing this reverse method. We have to check the periodic table to make sure that these ions match what's on the periodic table or even make any type of physical sense. If we look, we can see that iron is allowed to have a positive 2. And if we look at phosphorus, we see that it is allowed to have a negative 3 charge. If both of the charges are correct, then we can proceed to actually name the compound. If one of those charges are wrong, we have to do something extra. In this case, we don't need to do anything extra. So let's go ahead and name this. Since it has a positive 2, the element is iron, and because of the positive 2, again, we're going to use a Roman numeral 2 phosphide. So the final answer for this particular chemical formula, its chemical name is iron 2 phosphide. Okay, so in this example, we're going to have to do some work. We're going to have to do some real work here, but we're going to look at the chemical formula TIS and come up with its appropriate chemical name according to IUPAC. So we start by writing our formula at the bottom, Ti1S1. Okay, great. Now we're going to reverse that crisscross. We're going to make the subscripts become superscripts, and then we're going to crisscross them, and then we're going to add that positive and that negative sign back on. When we do that, we're going to get Ti plus 1 or 1 plus and S 1 minus. Now we have to do that important step, which is check the periodic table to make sure those charges make any sense. Let's look. Oh my goodness. If I look, titanium can't have a positive 1 charge. It does not like to have a positive 1 charge. And sulfur doesn't even like to have a negative 1 charge. So both of these are wrong. So how do we fix this? How do we find the right name? Well, since these elements are actually combined, they must be combined in the same ratio. So that means I can actually multiply these by a common factor and get the charge that I need. So in this case, we're going to use 2. We're going to multiply the charges by 2. When we do that, we get Ti2 plus and S2 minus. Let's check that periodic table again. Whoa, so titanium can have a positive 2 charge. Sulfur can have a negative 2 charge. Since both of the elements now match after we have multiplied them by a common factor, we can actually proceed to name this ionic compound. So guess what? Because titanium has a +2 charge, that means we're going to use the Roman numeral 2. So the final answer for the chemical name of this compound is titanium 2 sulfide. Titanium 2 sulfide. All right, so in this example, we got FeF3. Let's get the chemical name for this. So our first step, we're going to start at the bottom and write the formula. So we have Fe and F3. Once we reverse that crisscross, oh, what am I forgetting? Oh, I didn't write a 1. I did that on purpose. So when we reverse this crisscross, we're going to make sure that we get a 1 when we reverse this crisscross, okay? So when we reverse this crisscross, we get 3 plus for the iron, and we have 1 minus for the fluorine. Shall we check the periodic table to make sure that these make any kind of sense? Let's do it. Oh, look at that. Fe, iron, is allowed to have a +3 charge, and fluorine is allowed to have a -1 charge. So since they both match what is on the periodic table, we must be on our way to the right answer. All right. So let's finish this up. If we have a +3, then what Roman numeral are we going to use when we name this? It's going to be 3, 3 I's. Therefore, the final answer to the chemical name for FeF3 is iron 3 fluoride. Iron 3 fluoride. All right, let's get the chemical name for Vo, or Vo2, or VO2. Let's just say VO2. All right, I'm just trying to play around with y'all, have some fun. Okay, so same process. Let's do this. You write the formula. V1O2. Looks good, looks good. Let's reverse that crisscross. What are we going to do? What are we going to get? We should get V2 plus and O1 minus. All right. Now let's check that periodic table. Whoa. So vanadium can have a +2 charge, but the problem is, can oxygen have a -1 charge? That's a definite no. No. All right. So then what can we do? Well, we need to multiply by a common factor so that we can get these numbers to match what is actually on the periodic table. It has to make sense. If one of them is wrong, it's all wrong. Therefore, we need both of them to match what's on the periodic table. Okay, so let's multiply, in this case, by 2. 2 is usually a safe number. In some cases, you're going to have to use 3 or 4. But in most cases, 2 is an acceptable number to start with. So we multiply these charges by 2, and we get V4 plus and O2 minus. Let's check that periodic table again. Whoa, I see it. Vanadium can have a +4 charge. And look at that. Oxygen can have a -2 charge. Since both of the charges match now, we are well on our way to getting the correct answer. Therefore, let's go ahead and put this name together. Do you remember the Roman numeral for 4? It's IV. It's IV. So when we put this name together, we're going to name it vanadium 4 with an IV oxide. Vanadium 4 oxide.